Okay, so this should kind of look familiar. It should remind you of when we went over the triangle congruency. Um, so you might have seen like the SAS or the SSS before. So the difference between congruent and similar figures is congruent means they're the exact same shape. So all of the sides match up with the sides and all the angles match up with the angles. In similar figures, there's they pretty much they look similar, but they're not the exact same. And there's a specific definition for similar figures, and it is all corresponding angles are congruent and corresponding side lengths are proportional. So if you were given any figure, okay, you have two of them. My example I always use is like a picture frame. So let's say I have a smaller picture frame and then a larger picture frame, and they look like that. If we look at their angles, the corresponding angles that match up, they are congruent. And then side lengths are proportional. So that's the part that we're going to be talking about. We need to set up ratios to see if it is correct. And we're specifically just going to be looking at triangles for this unit. So first one, so instead of always having to check all angles and if all side lengths are proportional, we can take shortcuts with triangles. So we don't have to match every angle or match every side length and make sure all side lengths are proportional. We have three different shortcuts. We have the AA similarity, SSS similarity, and SAS similarity. So those are our three shortcuts. First shortcut, AA similarity, is if two corresponding angles are congruent, then the triangles are similar. So for this example, at first glance, it looks like there isn't two angles that are congruent. But if you do the math, you will see that angle C is 31 degrees, angle E is 74. We actually have all three angles which are congruent, which makes sense because by definition, similar triangles have all angles that are congruent. But all we need to know is at least two. If we have two, we can say that they are similar. So we would say that triangle ABC is similar to triangle DEF. And the reason for that, it's by AA similarity. Okay, let's look at the next example. So for this one, you're looking, it's clearly marked that V and Y are the same, or they're congruent, but also remember vertical angles. So those two angles are congruent. And without even knowing the angle measures, we have two congruent angles in each triangle, which means these are similar by AA similarity. You could write the similarity statement if you like. That is this right here. But you'll notice in other examples, you might not be able to because they're not labeled. Next one. So side similarity. What that means, if three corresponding sides are proportional, then the triangles are similar. So corresponding sides, we need to look at the sides that match up. So QP matches up with TS, QR, change color, QR to TU, and then PR and SU match up. And then we have to write proportions for them. So I'm going to start with QP, which is 3, and I'm going to write it over the one that's corresponding, so 3/6. Okay. I started putting the smaller triangle on top, so I want to continue that pattern. So then I'm going to put 5/10. And then last but not least, I'm going to put 4/8. Okay. You could have done it the other way, but just make sure that you stay consistent. So if all the top numbers of the proportions come from the small triangle, all the bottom ones come from the large triangle. So you just want to stay consistent and then check. Do these equal each other? They do. So they're proportional, which means that these triangles are similar by SSS similarity. Let's move on to the next one. Again, you're going to match them up, and so you're going to set up proportions. And you're going to see, are they equal? This one might not be as easy to notice, but if you plug it into the calculator, you will find that they are proportional, which means they're proportional by side, side, side similarity. Okay, and last one, side, angle, side. So you need two corresponding sides that are proportional, and the included angle is congruent. Then the triangles are similar. So let's look at this. So KJ matches up with NM, and KL matches up with NP. And as you can see, it is the included angle. Remember, that's the angle that is formed by the two corresponding sides that we're looking at to see if they're proportional. And then we just need to write it out. So 8/6 and 20/15, are they equal? They are, so they are proportional, and the included angle is congruent. Okay, let's look at this very last one. This one is sometimes is easier to just kind of draw it off to the side instead of having them together. So this side length on the large triangle is 60. This is 12. Down below, this is 45, and this is 9. Here's where it gets a little weird. On the little triangle, this is 11, and I know that this doesn't look correct, but from M to K, that is 44 plus 11. So that would be 55 here. Okay. Now you might say, well, I know all the sides. I could use side, side, side similarity. And you could. You could check to see if all of these are proportional right now. But I do want to point out that angle K on both of these, because they share this angle, are congruent. So really we could just check 2. So I'm going to check, just check the 2 sides because I want to use side, angle, side. So again, maybe I want to use the smaller triangle first. So then that one's, the numbers are going to have to go on top. Okay. And are they equal? Yes. So this is proportional by side, angle, side. Or sorry, this is similar by side, angle, side similarity. Email me if you have any questions. Please do the practice worksheet.